It is my great pleasure to welcome you to the world of learning new concepts and current trends, so let's start. Imagine looking at a database table with 20 columns, and half of them are completely blank. Take a standard user table. A customer doesn't have a salary, and a staff member doesn't have loyalty points. When you shove them both into a single entity, you get a sprawling table full of empty, null values. Standard database models struggle here. Staff and customers share names and emails, but their specific data needs branch off. To build a clean system, we have to pull those shared traits up and split the unique traits apart. This is enhanced ER modeling, or EER. We create a parent entity, called a supertype, like person, that holds the shared attributes. Below it sit the subtypes, staff and customer. These subtypes inherit the primary key and all the shared data from the parent. By using inheritance, we eliminate the blank spaces. Every row of data finds a precise home, accurately matching how the business actually operates. But there is a trap here. It is incredibly easy to over-engineer a database by turning temporary business states into permanent architectural structures. The rule for EER is strict. You only create a subtype if it requires a unique attribute of its own, or if it participates in a unique relationship with another entity. Look at this account structure. Branching it into active and closed subtypes is a mistake. An active account doesn't have different structural data than a closed one, it just has a different status. We strike it out and collapse it back into a single entity with a simple status attribute. Database architecture manages distinct permanent data requirements. If a record is just going to change states over time, it belongs in an attribute, not a whole new subtype. Once you have valid subtypes, you define how they behave using a constraints matrix. The first question is exclusivity. Can a parent instance belong to multiple subtypes at once? If it can only be one, we mark it with a D for disjoint. If it can be multiple, we use an O for overlap. The second question is completeness. Does every single record in the parent entity have to belong to a subtype? If yes, it requires a double line for total specialization. If a parent record can exist on its own without fitting into a child category, we draw a single line for partial specialization. Let's apply this to a university database. You have a person supertype. Below it, student and alumni subtypes. But your campus also has external contractors who don't fit either category. Pause the video for a moment, look at the rules, decide which exclusivity letter and which completeness line apply to this specific campus structure. Because someone can be a student and an alumni at the same time, the circle gets an O for overlap. And because contractors exist in the person table without being students or alumni, we draw a single line for partial specialization. Locking in these specific symbols forces the database engine to reject bad data later on, keeping impossible scenarios out of your system. Drawing shapes is just the first step. Now we have to prove the model actually works by running real business transactions through it. Take a look at this rule provided by the client. A manager must be able to assign a specific staff member to a VIP customer. We can logically trace the manager assigning the staff member, but the path hits a hard stop. There is no line connecting the staff member to the VIP customer. The transaction fails. To fix this, we update the model directly, adding a many-to-many relationship between staff and VIP customer to close the gap. A conceptual model is only complete when you can play through every required business action and trace a clear path from start to finish. Every time you find and fix a gap like that, you document it in a validation notes log. A solid log entry has 4 parts. The issue: we couldn't assign staff to VIPs. The evidence: business rule number 4 required it. The change: we added a many-to-many relationship. And the why: it ensures we can trace assignments. This documentation is the hard proof of your reasoning. It is exactly what stakeholders need to sign off on the design, and it provides the clear traceability required in academic assessments. You enforce unique traits by splitting out your subtypes. You constrain them properly with overlap and partial specialization rules, and you prove the structure works by testing it against real transactions. Systems rarely break because someone typed a bad SQL command. They break because assumptions were left unchecked, and logic went undocumented during the design phase. Lock down your conceptual model, and the code will follow.